All right, we're working on day one worksheet graphing exponential functions here. I don't have a printer, so I'm having to write all my stuff out. I imagine some of y'all are in the same situation. If you can print them out, it's of a great advantage to you. You don't have to waste your time writing all this stuff, and then you also have nice graphs and whatnot. But what you're going to need today is you're going to need pencil, paper, and a calculator. We're going to be using our calculator pretty significantly today. So let's get started. Number one, it says 2 to the power of x. If you remember, our exponential function is a times b to the power of x plus c, right? That's what we talked about before. This shifts the graph. It can be a negative or a positive a. It can be greater than 1, less than 1. Hopefully, when we work through this, you'll be able to see what a is doing. Or you can change it on your calculator over and over and over again to see the effects of a. B, same thing. When b is greater than 1 versus when b is less than 1. That's also in the main video that we made earlier. And then C is our what we add on to the back. It's our vertical shift whenever we're talking about other types of graphs. So it plays a very similar role in this one. Hopefully you can identify it. If you haven't already watched the video, hopefully you can identify it while we're working through these problems. Another thing I would like you to add to this is growth or decay. I would like you to identify each of these as growth or decay. As a reminder, when x is increasing and y is also increasing, so when we move from the left to the right and we're moving up slowly or quickly, that's going to be considered growth. When x is increasing, so when we move from the left to the right and y is decreasing, going down, that's decay. So anything trending this direction is growth, anything trending this direction is decay. All right, let's work through this one. Remember, I like to make little tables to help me out whenever I'm graphing. You don't necessarily have to do that, but you can also find that in your calculator. So for starters, I'm going to write 2 to the power of x in my calculator under y equals. So 2 to the power of x. And then instead of hitting graph, I'm going to go straight to a table. And remember, we like to use when -2, -1, 0, 1, and 2, when x's are those 5 values. And we're going to get negative point, nope, not negative, 0.25, 0.5, 1, 2, and 4. So 1, 2, 3, 4, 1, 2, 3, 4. And you can make these any size you want. So whenever we experience bigger graphs later on, I can make a tiny graph or a big graph or whatever I like. All right. So when x is -2, we add 0.25. So about a quarter of the distance up to this line right here. So something about, when x is -2, 0.25. Somewhere like that. When x is -1, it's about 1/2. When x is 0, it's 1. When x is 1, it was 2. And 2, it was 4. So we're going to get this cool little trending graph that goes down this direction. And it's going to get closer and closer and closer to that 0 line as we go along. If you look at your calculator, those numbers get really, really small. If you can't see this one, we'll focus here. Come on. There you go. You can see these numbers get really, 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 really small. And then they even start speaking about them in exponential terms. All that means is times 10 to the power of whatever this is going. So move the decimal that many places to the left since it's negative. So we're going to be moving that one the decimal 4 places to the left. So it would be 0.00098 something, right? That one would move 5 decimal places to the left. So it would be 0.00061 something, right? So really, really, really small. And then finally, your calculator will eventually freak out and either say error or 0. Okay? So those numbers are getting very close to 0, but never actually becoming 0. All right. And of course, as the numbers get larger, it gets really large really, really quickly. Okay? So on number 15, we're talking about 6 digits. 14, we're talking about 6 digits already. right? It gets really, really big, really, really fast. So what's our x-intercept? Is it ever really going to touch this x-intercept? No, it is not. That will not happen in this scenario. Our y-intercept is at 0, 1 right here. You remember our y-intercept is whenever x is equal to 0, and that occurs, let's refocus here, that occurs right there at 0, 1. Our asymptote is that line when y equals something that it approaches but never touches, and that's when y is equal to 0. And is it growth or is it decay? Does it go up as we move from left to right, or does it go down as we move left to right? Well, it's growth. All right. Number 2 is 1/3 to the power of x. So let's see how this changes. We had 2 to the power of x, and it looks like this. Forgot my arrow. Whenever we shift to 1/3, remember I can do fractions inside of parentheses. That's pretty necessary. To the power of x, 1/3 to the power of x. I'm going to go straight to a table. It gets crazy numbers, right? My little table, come on, pen. From -2, -1, 0, 1, and 2, we're going to have, what is that? 9, 3, 1. 0.333, I hope you remember, is 1/3. And then 0.111, I already know it's going to be 1/9. Remember, it's just the same as this, but shifted. Okay? So -2 and +2 will be very similar to each other. It's 9 or 1/9. 3 or 1/3. So -3 would be 27. So this would be 1/27. Okay? That's how it works out. So let's make this graph really quick. I have to go up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The negative side really doesn't matter because I'm not going there. And then we have -2, 9. So -2 all the way up to the top 9. -1, 3. So like right there. 0, 1. 1, 1/3. So something like that. And then 2, 1/9, so something even closer, right? And then it was 1/27th and 1, on and on and on. And it gets really small. So we draw this cool little curve. And we want it to get close to the x-axis, but never really touch the x-axis. So do we have an x-intercept in this situation? If you want to look at your graph, you can go ahead and hit that too. Is that what we expected it to look like? Yes. Good. So it gets very, very close to the x-axis, but never touches it. So we do not have an x-intercept. Our y-intercept is when x is 0. So it's at 0, 1. Our asymptote is at y equals 0. Notice the asymptotes for these two problems were the same. Well, if you watched your notes video, you remember that the asymptote is just plus c. Notice this is plus nothing on the back, and this is also plus nothing on the back. So our asymptote is going to be the same for each of those. All right, and is this growth or is it decay? Well, while we're moving right from the left to the right, is the number getting bigger or is the number getting smaller, right? So as we move from the left to the right on this graph, we notice that it is getting smaller, so it is decay. All right, number 3. Number 3 is a little bit different. We have a negative inside of here, or is it negative on the outside? I think we should graph both to see if there's something different, and then we're adding 2 on the backside. Hopefully you already know what that changes. So I would like to graph both of those at the same, or graph both of those really quickly. And let's see what the difference is, or if there is a difference. Plus 2. I'm going to go ahead and hit graph on that one. I think I have a little light on here. Yeah, that might help out. Okay. And your calculator's thinking about it. See, it kind of freaks out a little bit, right? Let's look at the table really quickly. And what is it doing? Oh, do you see how it's alternating positive, negative, positive, negative, positive, negative over and over and over and over again. Okay, your calculator's freaking out a little bit about that. Whenever we have a negative value inside the parentheses and we raise it to a power, whenever it's an even power, it's a positive number. Whenever it's an odd power, it's a negative number. So whenever we graph it, your calculator freaks out. Well, so I imagine that that's not what they're talking about. It's more this situation where there's a negative on the outside. Let's see what that happens. Let's see if that changes anything. We're going to put our negative on the outside of the graph. Let's hit it. Hey, your calculator doesn't freak out about that one, and it gives it a nice, pretty little graph. So we're going to look at our table, and we're going to say when x is -2, -1, 0, 1, and 2. Y is 1.97, blah, 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 blah. So something like that. 1.83. We're going to go with 1. We're going to go with -4. And we're going to go with -34. Oh, my goodness gracious. That gets really small really fast. So let's go ahead and draw our graph real quick. So positive numbers, negative numbers. All right, so when x is -2, y is almost 2. Almost 2. When x is -1, y is a little bit less. When x is 0, y is 1 again. That seems to be a pretty common trend. When x is 1, y is -4. So 1, 2, 3, 4. And when x is 2, y is off the charts negative. Let's look when x is -3 and -4 and -5. Do you see what number we're getting close to? -6, it went ahead and gave up and said that it's so close to that number that we might as well call it that. Okay, so let's draw our little graph. And that's about what it's going to look like. We do have an x-intercept. Hey, look at that. When y is 0, right? So we need to find that number. It's going to be in between 0 and 1. I already know that. So we do have an x-intercept. We do have a y-intercept, and that one's clear when it is at 0, 1. And then we have an asymptote. What number are we getting really, really close to but never really touching? And that's when y is equal to 2. Is this going to be growth or decay? Well, when we're moving from the left to the right, is it getting smaller or is it getting bigger? It is getting smaller, so it is decay. Now, how do we find out what that value is? If you recall, we can use our second calc feature to find our 0. And then we want to do the whole left bound, right bound thing. So to the left of that x-intercept, yes, I am. To the right of that x-intercept, yes, I am. Guess about what that x-intercept is, and then it tells me it's this crazy number right here. So we're going to go with 0.3, let's call it 39, comma 0. And so it happens in between 0 and 1, but closer to 0 than 1, right? So 0.39, comma 0. All right, on to number 5. Let's see what changes with 5. Now we have something on the outside. By the way, let's look at this real quick. Number 3, our negative made it reflect across the x-axis, and then we shifted up 2 units. So our original thing looks like this. Then we flipped it across the x-axis. Then we shifted it up 2 units to get to here. Okay? So that's everything that's going on here with our shifts. Our A controls that reflection and the vertical stretch or vertical compression, just like our quadratic function did. Our B controls if it's exponential growth or exponential decay. And then our C shifts it up or down. Now, if we show growth, but it's negative, then it turns to decay. Okay, so without that negative, it would have been growing. But with that negative, it is now decaying. Okay, we're almost out of time. I'm going to stop this video and move on to the next one.